We're also beginning to see a new inflection point occur, and this is what I will describe as hybrid systems. And we will lead the movement towards hybrid systems, which is taking this notion around fit for purpose. And we think that we will be driving new capabilities here where the systems will be tuned to the application workload. And really the thought to take away from this is there will continue to be an emerging class of workloads across all industries with these real-time characteristics and the need to predict, to extract the intelligence. And you can just see a number of those that are listed, and you'll hear from other speakers like John Kelly, who will actually focus on a very specific set of examples. But think about this hybrid system being taking the capabilities of a general-purpose system, and general-purpose systems today do a very good job in terms of dealing with multiple workloads, in terms of consolidation, and also providing the secure transactional platform, and then integrating into those systems new types of accelerators that are tuned to the characteristics of the workload. So we'll be doing different types of specialty engines that will optimize the workload performance. And then you wrap that with integrated systems management because we will continue to drive advanced virtualization and automation for a dynamic infrastructure. Well, good morning and welcome back. Let me share with you, first and foremost, what are our research priorities in IBM. As you know, we spend between $5 and $6 billion a year on R&D. Now, I'm often asked, well, John, what are the big breakthroughs? What are the things that are going to change this industry? What are you guys working on in research? This is a list that is a very important list, and it's the list that, in addition to all the other hundreds of projects we're working on, we have large masses of resources focused. I won't touch on all these today, but the first thing you need to sort of gather from this is the impression we're working on everything from atoms and molecules and nanotechnology up through services quality, and all of the hybrid systems and software in between that we talked about this morning. So in the spirit of time, I'm going to touch on just a few of these to give you some insights. The first one we talked about a little bit before around this concept of hybrid computing. And again, existing applications will continue on in time, but what's new are all these things in this outer sphere, if you will. The XML, the high-speed transaction, the connected sensors. These are the things that are going to drive not only the future applications, but much of the growth in our industry. Today's general-purpose systems, as Rod articulated very, very well, do many of these things well. They could do these things in the outer sphere, but frankly speaking, they won't do many of these things at the kinds of performances and with the reliability that are needed to do this well. So a whole new class of systems called hybrid systems will be built that leverage these general-purpose processors and do these purpose-built, special-purpose things. Let me show you an example. Here's a case of a key hybrid system that we're working on at the interface of enterprise servers, and networking. It turns out that if you build a very special purpose processor with very high speed I/O, the proper memory, and the proper number of cores and threads, you merge that with the right protocol-based networking software around security, such as our ISS software. You put that in the right form factors from our systems group. You put that all together, you get something which isn't 10 or 20% better. You get something which is 50x faster. What this system will be capable of doing at wire speeds of 10 gigabits per second, it will open and inspect every packet at line speed. Today that's done on a sampling basis of 1 in 100 or 1 in 1,000 packets. This will open and inspect at 10 gigabits per second, and it's extendable to 40 and 100 gigabits in the future. Even more dramatic than that, as we project forward from petascale today, shown on the left are three of the world's largest compute capabilities. The top one on the left is thousands of servers at one of our largest financial clients. In the middle is an aerial picture of a very large search company's data system. It's a building. And below that is our Roadrunner 1 petaflop system. Applying the technology of exascale computing and hybrid principles inside these systems. Exascale hybrid systems will be able to do all of that in 3 racks. So the technology advances, and the capability of hybrid systems will do amazing things for us going forward. And it's not just the sheet metal racks. It's the system management that allows the workloads to be managed across this complex system. Stream computing, another major technology breakthrough that I think is going to be transformational for our clients in the industry. What happens today? Well, today when a financial institution, Steve mentioned TD Bank, has, I show 4 feeds from weather services, financial institutions. When you have hundreds of feeds coming in at 10 gigabits per second, the way it's done today is it's all put into a system, it's stored in storage, and it's pinged. It's pinged for information. It's after the fact, very slow. What we have been working on is an entirely different system architecture called stream computing. And what it does, and Steve alluded to, is it doesn't store all the information at once and then do the analytics. It does the analytics on the fly. It embeds the analytics at every node in the software where a decision needs to be made. And it can be instantaneously programmed to do the analytics in real time, so that you go from pinging of seconds and milliseconds response to getting complete information in microseconds, which is very important if you're in a financial situation or if you're in a real-time, real-world aware, smarter planet implication. We've been working on this technology, as Steve mentioned. We took this capability of stream computing, realizing that financial institutions could be optimized on a high-performance computer, put it on a Blue Gene computer, and realized, not 10 or 20% improvement, but 21x performance improvement for TD Bank in options trading with this real-time system. So again, transformational things, not sort of linear improvements in technology. Since I'm running out of time, let me sort of sum it up here with a project which, again, I think will be transformational, and I think it represents all of the capabilities of the IBM company and the kinds of investments that we make. 2 weeks ago, we announced that we were going to build a large computer system that is a question and answering machine, a QA machine, and that we were going to put that machine up against the grand challenge. Just as we took on Garry Kasparov in chess years ago and beat the Grand Master, we're going to take this Q&A machine and put it up the best and brightest in Jeopardy. Now, this is not about games. This machine, codenamed Watson, is all about, think about it, taking enormous databases, doing analytics, and getting to one answer. So somebody asked me a couple of weeks ago, well, John, isn't this really just search on steroids? It's not search on steroids. Let me just briefly explain to you how this thing works. On the left side, it will ingest the question. It has to understand the text of the question. It has to understand what it's asking for. It has to translate the question into something that it can search on. Then it's going to do some very rapid preliminary searches, the second box on the left in the chart. All of today's search technologies reside just in that second box on this chart. This will do that search. It will come back with lots of information, subsets of what it found in its databases. It will then start to put together a series of possible answers. It will then go out and research and look for other information that will help validate what it has concluded might be the answer. Brings it back in, does a statistical set of analyses, does another search, and finally calculates in deep analytics what is the probability that the answer it's arrived at is correct, and what is the probability that it should bet on that answer, in this case in the Jeopardy. And by the way, we have less than 3 seconds to do all of this. So it's an amazing capability. It's not a pipe dream. It's up and running. It already has the capability to beat, you're smarter than I am, it beats me. It probably would beat many of the people in this room at Q&A. It's an incredible capability, but it's not about games, and it's not about search, and it's not about just having some fun. It's all about trying to go way beyond search and trying to deal with large amounts of data in real-world situations where you need very rapid single answers and known probabilities so that you can make decisions to affect real-world events or business events. So as we look at the opportunities for such a capability, the obvious answer is call centers or areas where you want to raise the quality of the answers that you're offering. But think about areas like healthcare, where in healthcare it takes a decade, even in the U.S., to get the latest medical procedure to half the physicians in the U.S. Think about having a machine of this capability in every emergency room in the United States. So that a physician can ask the question, patient has these symptoms, what should I do? It will come back with not 1,000 pages off the web or 100 pages off the web. It will say, it's likely this with this probability, very high probability. Transformational, I think, in business analytics going forward.